Okay, we're at about 40 minutes. Give me a moment.
As I was saying, EJ, up
There
on
we
the
go.
roof,
Fixed
give
it.
everybody just a couple minutes of what it was like your first time here watching Starship and Super Heavy lift off, and then booster 15, sorry, 14
Okay,
coming
1
back
second.
and liftoff.
Well, if you guys have watched me before on Twitch, you watch me any of my reactions to rocket launch, I get rather enthusiastic during these launches. This time, I had no words. The awe of seeing this thing go off, and I'm not just trying to do that to blow smoke up Starship, right? There is nothing else like this. I am usually, screaming, having a good time, like, oh man, look at that thing go. Oh my goodness, this is crazy. The building's shaking, sonic booms, yeah. I was just there like, wow, you can tell it's a rocket because the way it is. That's pretty neat. That's pretty neat. I was just dumbstruck by this thing.
Yeah.
It's crazy seeing this thing fly.
The first time I saw it, it was like a 12-year-old again, and you just become a kid because you're like in awe of this amazing rocket. And I remember telling you, take the headphones off, and we can hear, they block a little bit of sound, and that's not what we want. We want to hear those engines roar when this thing lifts off, and hopefully we will hear the engine roar in about 36 minutes and 40 seconds. By the way, as I was saying, we can do all this because of you guys. And Michael Covilio, thank you so much for that $50 super chat. Says, stellar work, NSF. Thank you for all your dedication and sharing. Michael, this is an absolute privilege for all of us to be here and do this and bring you these. That rocket's getting cold. Alex is giving the burr signal that rocket's getting cold, isn't it, Alex?
Yeah, I was sort of doing like, ooh, frost, it's cold.
And as the tanks start to fill, I mean, we're going to see these frost lines, right? Go ahead, Adrian.
It's also quite fascinating because people maybe would expect there's a tank inside this. What you are seeing is the tank wall.
Mm-hmm.
This is not like there's not like a inner LOX tank or like an inner methane tank. What you're seeing there is literally the wall freezing because it comes in contact with the liquid oxygen and with the liquid methane
I did not know
inside
that.
of the vehicle. You're literally seeing the tank wall freezing up, which I think is so fascinating. That's what you're seeing there is ice.
Yeah, it's crazy.
I didn't know that literally
think,
was
as you
the fuel
said,
tank.
that there would be a tank within the wall. The wall is the tank. And as that fills up, we'll see how much fuel. And as we talked about, every time we do this, it's like a progress bar. Watching that fuel go into the rocket, into the Super Heavy booster, and as we get closer to that. T-minus 35 minutes, and at T0, excitement is guaranteed. Now, Alex, let's talk about Monday, okay? We just want to refresh everybody what happened on Monday, because all the guys in the control room, the folks in the control room are watching all the gauges and pressure sensors and all of these things going on, and they're looking at the health of the vehicle. They're looking at the health of the Super Heavy booster. They're looking at the health of the tower. They're looking at the health of the ground support equipment. So what happened on Monday when we got to a point and they started to call out holds, which they haven't done today, but we're reminiscing about Monday? What happened?
Well, we had that first sort of hold point, right? That was called at T-minus 22 minutes. Then we had commentary popping off there that they were going to run until T-minus 40 seconds. We had that T-minus 40 second hold. They tried to troubleshoot some of these issues. It seemed like at first some of them were cleared, and then once they lifted the hold and sort of they started they resumed the countdown, About 9 seconds later, T minus 31 seconds, the clock stopped again and recycled to T minus 40. And it apparently happened that, some of these automated health checks that happen once they lift the hold, it seems like they just had some kind of.
Do not buy new windows if you live in Tennessee.
Come on.
Americans living in zip codes starting with
Stop
37 and
And that's one of those things that we are not wanting to happen today, right? We're going into this propel load sequence. Hopefully this time they have a lot more luck with those systems, the ground systems, the vehicle systems. Definitely, hoping to hear good news from SpaceX as we count down to T0.
And as we count down to T0,
I'm
we
gonna
are
switch
looking
to
at
this SpaceX live stream.
This is a flashbang. It has a 2-second delay, but don't worry, as long as
Stop. Okay. Seems the stream hasn't really started yet. That live stream to start. This might, I don't know how long this is gonna take. Nope, it's starting. I haven't seen this intro before. That was pretty cool.
Good afternoon, Star people, and welcome to the 8th flight test of Starship. It's currently 5:01 p.m. Central Time here in Starbase, Texas, and we're looking forward to tonight's launch of the world's most powerful rocket. Great view there of the vehicle on the pad. I'm Kate Tice, Senior Quality Systems Engineering Manager here at SpaceX.
And I'm Dan Hewitt with SpaceX Communications. Welcome to our second ever broadcast from Starbase's new Star Factory building. First, if you don't count Monday. But we are at T-minus 28 minutes, 20 seconds, and counting down to a liftoff at the open of our window at 5:30 p.m. Central Time today.
3 days ago, we stood down from a launch attempt after triggering a few holds during the count, which had us hold at T-minus 40 seconds for several minutes, resume the count, and then trigger another automated hold. The final item that ended the day was when we encountered lower than acceptable pressure on the ground spin start system for 2 of the outer engines on the Super Heavy booster. All Raptor engines use high pressure gas to start up, and we use gas stored on the ground side to start up the 20 outer engines on Super Heavy. By the time this automated hold appeared and the team started to work through it, we also triggered a hold on the booster LOX levels and had to call it for the day.
We were able to trace the spin system issue to just a misconfig on some of the ground hardware, so that had a really straightforward fix. We just took the time, though, to look into some of the other items that resulted in holds throughout the count, including some of our automation was triggering holds on the booster, which we were able to actually clear during that launch attempt by confirming the hardware was healthy, and we had some manual commanding backups. We also looked at some pop-up hardware and software issues on the ship, and just to put us in the best possible spot for a launch today, we destacked Starship, did some repairs inside a ship, and then ran some additional checkouts.
And that brings us to today, just about a month and a half after our last flight, which saw the second ever tower catch of the Super Heavy booster and the first flight of our upgraded ship, which unfortunately ended much sooner than we had hoped. It's important to remember that in development programs like this, progress is not always linear, and there is no comparison to putting flight hardware in a flight environment to learn as fast as possible. We always want to be in the best possible position to achieve our mission objectives, which is why we stood down from launch on our previous attempt and took the time over the last few days to get ready for launch.
Now, the objectives for today's flight going to look very similar to Flight 7. As always, primary payload for these flight tests is data. We are planning to deploy some simulated Starlink satellites and fly a range of experiments focused on reentry. We removed a whole bunch of tiles again from the ship for reentry testing, looking to really stress test it.
We'll also be intentionally stressing the flaps during reentry so we can test the limits of ship before we get ready to attempt future ship catches. So there is a lot of new testing happening today, and as always, excitement is guaranteed.
Now, just a real quick status check. So you could tell we're loading prop onto the vehicle. We're able to get through our prop load go, no go just about 40 minutes ago. And we are loading liquid oxygen, liquid methane on both vehicles, not tracking any vehicle problems, issues on either booster or ship. Weather is green right now. Winds at the pad are actually significantly lower than they are even just for us over here at the Star Factory. Just a couple mile difference makes a big change in those wind speeds. And range is currently projected to be go, but we are always watching any boats that are out there in the ascent and the entry.
Okay,
Now,
that's good.
let's take a couple of minutes to meet today's vehicle. Sitting there on the pad, it's the world's biggest rocket, Starship.
Starship consists of 2 stages, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Both stages are fully reusable. Super Heavy is the most powerful rocket ever flown and is designed to launch, return, and refuel, and launch again with 0 refurb between flights.
And then everything else you see around Starship, we refer to as Stage 0. That includes the towers. We've got our second launch tower stacked on the left side of your screen there, getting ready to come online later this year. It also applies to orbital launch mounts, our quick disconnect systems, everything on board. Also the water-cooled flame deflector, which is right underneath Starship. That's a particularly cool piece of engineering. It uses several 100,000 gallons of potable water to offset the pretty intense heat pressure coming out of those 33 Raptor engines at the bottom of the Super Heavy booster at the time.
That
of
is
this
so much
You
water.
mentioned engines. Of the 6 Raptor engines on the ship, 3 of those are optimized for sea level performance and the other 3 for vacuum. Raptor Vacuum, or RVAC, well, those have a larger exhaust section and expansion nozzle to maximize efficiency in space, as there's no atmosphere up there. The ship as a whole is designed for vertical takeoff and landing on any hard surface.
The ship itself has 4 flaps that are used to control its attitude and enable precision landing during subsonic flight. And then for full reusability, the ship has to survive re-entry not just once, but multiple times. It does that by using that heat shield, which is composed of those thousands of hexagonal ceramic tiles, which can insulate the vehicle during re-entry, temperatures spiking up to about 2,600 degrees Fahrenheit in some spots. And a rapidly reusable heat shield has never been flown on any vehicle in history. So continuously improving the one we have, Starship, is still a key focus of our flight test campaign.
And of course, in between our first and second stages is our hot stage. Hot staging is when the second stage engines ignite while still attached to the first stage. There you can actually see a video of our previous hot staging maneuver, or executed on a previous flight. And how the ship's engines light while it's still ignited while the booster's engines are still firing. Basically, the rocket never stops accelerating, which makes it more efficient than traditional stage separation.
And then after we launch the booster, we also have to catch the booster. And we do that by using the 2 robotic arms, the same ones that lift Starship onto Super Heavy before we launch. They also catch the booster when it returns. It means we don't have to have any landing legs in the booster. That's a lighter booster. It means we can put more payload, more stuff going to space.
Thousands of criteria must be met before the booster can return and be caught. It requires a healthy systems and manual commanding from the flight director.
Audio
Just
is
like on
low.
our previous flights, if that command's not sent before the end
Just
of the
do
boost
that.
back burn, or if those automated health checks running in the background
Is
find
that
any
better?
unacceptable conditions on the booster or the tower, they'll kick us out, and the booster can default to a landing burn and a soft splashdown out there in the Gulf.
Yeah, we've said it before. We'll say it again because it still holds true
Why the
today.
heck does it
We
say there's
accept
10
no
viewers? It's
compromises when
literally
it comes
just
to
me.
ensuring the safety of the public and our team. And the booster return will only take place if those thousands of conditions are right. So as the clock continues to tick down to launch, let's say hello to Chris, who's once again posted up in Hawthorne. How's it going, Chris?
Hey, Kate and Dan, and welcome everyone to Hawthorne, California. As you can hear and as you can see, the crowd is gathering. Excitement is really building here for Starship's 8th flight today. And speaking of flight, let's talk about the Raptor engines, which have quite a workout ahead of them today. Now, our Raptor engines are designed and manufactured right here in Hawthorne, and they have certainly accomplished some impressive things already. They've powered Starship in its first few flights around Earth, and they've helped bring 2 Super Heavy boosters back for a catch by the Mechazilla system at the launch site. But here at SpaceX, we're always looking to improve our designs, and we do this by using something that we call the algorithm. Now, for Raptor, the algorithm has helped us question the requirements for the engine, find the parts that we don't need, and then optimize the design for manufacturability and reuse. This allows us to simplify designs and drives us toward that rapid, reliable reuse. And as you can see on your screen here, it is definitely what we have done with the Raptor engine. Look at that beautiful family photo. You can really see how Raptor 3 is an unprecedented step forward in design. It eliminates the parts we don't need. It moves a lot of stuff inside the engine. And one thing that it also allows us to do is to delete the heavy engine heat shields that are used on the current version of Raptor today. And what that means is that when we switch to the Raptor 3 engine later this year, we'll be able to save about a metric ton of mass per engine. And when you multiply that by 39 or more engines, that's a lot of mass. And that mass savings actually helps us increase Starship's efficiency and the amount of payload that we're able to deliver to space and to Mars with Starship. But before we get to Mars, we still have a lot of important and critical development work to do. And it's flight tests like today's that help us do just that. Needless to say, the Raptor teams here in Hawthorne are very excited for today's flight and to see their hard work fly, just like all of our Starship teams are today for Flight 8. So Dan and Kate, back to you for some more info on Flight 8.
Thanks, Chris. You mentioned development. Let's talk about things that we learned from our last Starship mission. In January, Flight 7 of Starship generated lots of important data. That data led us to change some of our pre-flight testing for today's flight. A major find from Flight 7 was the detection of a stronger during flight than anything we had seen during testing.
That's right. Rocket engines create incredible amount of noise, vibration that can pass through every component in the rocket itself. Flight 7, we saw those vibrations at a specific frequency. They were also strong in a strong enough amplitude that it was placing a lot of extra stress on some of Starship's propulsion system. And that's what most likely led to propellant leaks that then cascaded into fires and ultimately our loss of contact with the ship.
As part of our investigation, our team took this flight's ship through a 60-second static fire, which was 10 times longer than any previous static fire. The test cycled through throttle levels to recreate different conditions seen within the propulsion system during flight. You can see that on your screen now. We also tested hardware changes on fuel feed lines to Raptor's vacuum engines.
The additional data we got from this test specifically led to some new hardware that's installed in the RVAC fuel feed lines, which are also unique to this upgraded version of ship. Those feed lines look like large straws. They run through the oxygen tank, and those are delivering fuel directly to those vacuum engines. The new hardware was successful in significantly lowering the strength of that harmonic resonance and relieving the extra stress on the prop system. And then just in addition to new hardware, we made a couple of operational tweaks, adjusting things like the temperature of the propellant as it's being fed to the engines, also changing the throttle level that we're setting those engines at on ascent.
We also looked at where fires broke out in the attic, which is the unpressurized space between the bottom of the ship's liquid oxygen tank and the engine heat shields. Fires here resulted in loss of ship on flights 2 and 7, so we took steps to make it more resilient to leaks. We added a hefty purge system that uses gaseous nitrogen. Similar to the carbon dioxide system on the booster, it floods the zone with an inert gas to help prevent a fire.
Yeah, we also increased the attic's just natural fire defense. We added some more vent holes that helps to keep that attic pressure close to vacuum as Starship flies into space, makes it harder for a fire to ever exist. And then on the next generation ship, we're going to do the best thing possible and just start deleting some parts.
Yeah, the best part is no part.
The next generation of ship is going to use Raptor 3 engines, which are going to reduce that attic volume, and they're also going to eliminate most of the joints.
Where is it getting this information?
That
It
can
is
leak
just
into
raw.
the space.
Streamlabs.
In the end, these changes represent the core of our test program. We fly hard.
Yeah, there's nobody in the stream. Why does it say that there's 9 people? Okay, whatever.
Us, as always, starts with liftoff, and that's super heavy, igniting those 33 Raptor engines, lifting off from the pad here at Starbase for that initial ascent. All 33 will burn for the first roughly 2 minutes before we get into hot staging.
For hot staging, the second stage will ignite its engines while still attached to the first stage. That will create that stage separation. The booster will perform a flip maneuver and head on back to the launch site here just behind us. Then we will hopefully see the third ever tower catch by the launch tower.
Meanwhile, ship completes its ascent burn, gets into its suborbital trajectory. We've got some extra things we're going to do in space, like deploy those Starlink simulators. Also going to be relighting one of the Raptor engines, one of the sea level engines, before we get into re-entry.
Yeah, that re-entry phase will test multiple experiments, including missing heat shield tiles, metallic tiles, and loading the vehicle's flaps. The ship will then perform a flip maneuver and hopefully achieve a soft water landing as we have seen before. We've got some buoy cams stationed out there to give us great daylight views of that splashdown in the Indian Ocean.
Yeah, it's a lot, but again, we're really focused on finding what are the real world limits of Starship. We're doing it in this very remote area to find those limits before we get ready to return ship to the launch site and eventually catch it. And a lot of the upgrades we made to get to this version of ship are going to enable
I'm so
that.
where is
Man,
YouTube
it's gonna be
getting this
exciting to see
information?
ship
It's going to be
catch.
wild.
Now,
Yes,
Ship
it is
7 premiered
faulty.
a huge block of upgrades to add more capability to Starship, and we've carried them through to test on Flight 8 today. First, the forward flaps got a redesign. They have shrunk and shifted away from the ship's belly or the heat shield. You can see that on your screen there. This new position will reduce their exposure to heating during re-entry. We've also extended the length of Starship, and we've done this by 2 meters. This additional height gives us about 25% more propellant volume, which will aid in future longer duration missions. We also implemented propulsion upgrades, such as new fuel feed line system for the Raptor vacuum engines, as well as vacuum jacketing of feed lines and an improved propulsion avionics module.
And you've heard us talk, a lot of the experiments we're running today are focused on reentry. We're intentionally removing a whole bunch of tiles all over Starship itself in this missing tile test. They're removed in critical areas this time, including over those propellant tanks, around some of the flaps, as we're really looking to use this flight to push Starship's capabilities. If we're not resilient to a missing tile and the backup ablative underneath, we need to know that.
Okay,
We
we're less
also
than
test a
15
couple of
minutes
different
away.
tiles on Starship, some metallic ones, one of which
2
has
minutes
some
ago.
active cooling built into it.
Avionics also underwent a complete redesign with 4 upgraded Starlink terminals. You can see the location there popping up on your screen. Those now combine Starlink navigation and radio frequency, as well as communications into a single unit. And non-structural versions of the ship's catch fittings have been installed to test thermal performance, i.e. do they survive re-entry, along with smooth and tapered edge on the tile line to address hot spots we covered and saw in Flight 6.
And we've got some radar sensors on the tower catch arms again, as we're just looking at different ways to measure distance between the arms and a vehicle. These ones are actually protected by kind of a modified version of our heat shield tiles. Catching the ship's going to be a little different from catching a booster. One of the key things is it's going to do that flip right before its landing burn that rapidly reorients your antennas, which you're using for navigation. So those extra sensors on the ground side help just add more layers of control as ship and tower talk together for the catch.
And in another first, Starship will deploy 4 Starlink simulators. They are similar in size to our next generation Starlink satellites. Starship will have the ability to deploy our advanced V3 Starlink satellites, which will help further Starlink's impact in the coming years as we work to expand access to high-speed internet all around the world.
Each Starlink V3 launch is planned to add about 60 terabits per second of capacity to the Starlink network. To give you some perspective, that's about 20 times the capacity we're adding right now with every V2 mini launch on a Falcon 9. Those Starlink simulators that we're going to deploy are on the same
I've noticed that, like,
trajectory
none of these streams
as Starship
have it.
itself. They're expected to demise upon entry. Starship's trajectory looks super similar to our last couple of flights. Splashdown is targeted for the Indian Ocean. And then on top of all of that, again, we are planning to relight one Raptor engine while in space. That just helps us get data on the in-space burns and show Starship is capable of deorbiting.
Speaking of deorbiting, thanks
I'm just
to...
gonna kind of mute until we're at like 5 minutes to launch. Just leave the background music going. I think that'll work. Okay. So, about 4 minutes to launch of Starship Flight 8. Oh, a little bit of a buffer there. So, this flight, the goals are the same as Flight 7. Attempt a booster catch, have Starship Block 2 not explode, and deploy some dummy Starlink satellites. And then hopefully survive re-entry with all of those missing tiles they have. Hopefully all of that will be successful. Let's see what they're talking about right now.
Starship are super heavy. That's why we essentially have several minutes where we can hang out at that T-minus 40 hold point before we start to run into issues with temperatures or just those LOX levels, or that LOX level on the booster is one of the main things that we watch. So we're also going to do a couple of final checkouts. We'll do one final one of the thrust vector control, the TVCs on the booster. We'll see them hopefully do a little bit of a wiggle test. The first one comes at about 1:40 before launch, and then the last one comes right as we pass that T-minus 40 gate. Again, if we need to hold, which we held a couple of times on Monday, we can do so at that T-minus 40 second. We're not currently tracking any issues that would hold us there, but if we do run into that, we can hang out for a couple minutes.
That would be the point in the countdown, as we mentioned on Monday. That T-minus 40 second point is when we can pause to hold for final checkouts or pressurizations if necessary. But once we pass that T-minus 40 second mark, a number of things are going to occur in rapid succession. The ground spin and ignition systems will come up to flight pressure. The ship goes to internal power. And after that, the quick disconnect or QD arm lockout. That's removed in preparation for retraction shortly after T0. Once we pass T-minus 40 seconds, as we saw on Monday, we had the ability to recycle the count under certain conditions back to that T-minus 40 second mark and hold there to assess what happened and if we're able to proceed to T0.
And like we said, that we can hang out at T-minus 40 for several minutes before we start running into some limits, essentially, on our propellant on board. There are a couple of other things, like if we pass the T-minus 10 second point and the water starts to flow in that flame deflector and we scrub, that's automatic scrub for the day. Oh, there's our TVC, our thrust vector control checkout. It's got a little bit of a wiggle there on those inner Raptor engines, those 13 inner ones, which are going to be used for that boost back burn and the landing burn. So cool to see those.
Yeah, I love that shot. We don't have that on Falcon. And it's just so cool to see really the business end of the Super Heavy booster.
Okay, so I'm pretty sure it's going to be a hold of 40 seconds again. But I did have it muted, so I don't actually know.
10 seconds away from that T-minus 40 hold. We'll see.
Yeah.
All right, we are going to hold at T-minus 40. We're watching the temperatures on the ship right now for the ship fuel. Sounds like they're working through that. We might be able to release that hold shortly. All right, sounds like we're going to be able to reset those holds, not tracking any other holds. And clock is rolling.
And the clock is rolling once again. We're now T-minus 30 seconds till the liftoff of the 8th flight of Starship.
Our flight director, Joe Schleicher, today is go for launch.
Okay.
Let's listen in as he takes us through the final seconds of the count.
T-minus 8, 7, 6, 5, 4, 3, 2, 1.
we're a little over 40 seconds into the flight. We are seeing 33 out of 33 Raptor engines ignited. Boosters pushing us downrange over the Gulf. Next milestone coming up in just under 10 seconds is going to be max Q, that max aerodynamic pressure.
Max Q.
All right, so we're through max Q. That's the heaviest stresses it's kind of seeing on the way up. Wow, that was pretty incredible.
I'm still recovering. That was amazing. Beautiful views of the vehicle on ascent.
Oh, it looks so good.
Pushing downrange away from the launch tower.
Next thing coming up is hot staging. So we're going to look for 6 engines to ignite on ship while we're still attached to the top of the booster. We'll see all but those 3 center engines shut down on booster.
We're hearing the initial
I just
call
gotta
that
say,
we
I
are
nailed the
go
timing on
for
this there.
booster catch back here at the launch tower. Coming up now on hot staging, the ship's engines will ignite while still attached to the Super Heavy booster, and also while Super Heavy booster will still be under power itself. Clamps holding the 2 stages together are going to release. And Starship second stage engines will
Booster engine
ignite.
cut off.
That was awesome. And
Ship engine startup.
there's hot staging. Perfect.
Stage separation. Boost back burn startup.
So let's see if I can,
There we go.
where is it?
Ship engines, all 6 Raptors ignited. We're doing that boost back
Yes.
burn. Looks like we got 11 of the 13
Boost
that we
back
command
burn.
for
Call for
that,
booster
so
return.
that's going to start sending
Where's
the booster
song
back.
that
We
I
are
want?
still go for booster
can't
return,
find it.
even with 2 Raptors out during that boost
I
back. We
have
can do
too
a full
many
duration
songs
one.
in here.
Roger,
But
chamber push is nominal.
looks like we got a ship, 6 engines heading into space, and then we got a booster hopefully on our way back to Starbase. How's everything going in Hawthorne, Chris?
Here it is.
Everything is looking good. The crowd eagerly followed that ascent and now watching the booster coming back. So as you can see on the left-hand side of your screen here, that is ship continuing, and that's a great view of ship continuing on its way to space. They're looking, that's inside the camera, inside the aft skirt, looking at the Raptor vacuum and the sea level engines, the sea level ones there in the center of your screen under our T+ clock. You can
Okay,
see
don't
our
explode
boost back
again.
burn. We're down to 3 engines on the boost back burn.
That's all
And you can see ship on the right-hand side of that telemetry with 6
All it
engines
has.
lit, continuing its ascent to
do that.
orbit, already over 100 kilometers in altitude. The booster 87 kilometers in altitude and continuing its trek right now back to the landing site and catch site. There's a
Shutdown.
Oh, yeah.
and we just heard a good call out for boost back shutdown. The next thing we should see on our screen is the separation of the hot stage from the Super Heavy booster. We jettisoned that because we do not need it for the landing, but on future iterations of the Super Heavy, that hot stage ring will be incorporated into the booster and we will get it back. But for today, you can see it on the right-hand side of your screen there, just separating off from the right-hand side of the booster. You can also see the booster doing its liquid oxygen dump there, which is exactly what we would expect for it to do as the booster gets itself configured for the landing here. Now, meanwhile, Starship will continue to coast after it reaches orbit for about 40 minutes or so, up to an altitude of 214 kilometers, but it's still got a ways to go there, currently accelerating past 7,500 kilometers per hour there in velocity. And just look at those great views of the booster coming back. The Gulf coastline there just looks absolutely gorgeous.
Starship is on a nominal trajectory.
And there we hear nominal trajectories all around. And Dan and Kate, we're at 5 minutes, 15 seconds here into the flight. Everything looking good for the Super Heavy and for Starship today. What's it like there at Starbase as we get ready to catch?
It was incredible, Chris, to be able to see the mock diamonds with my own eyes. That was amazing. We are standing by for return of booster back to the launch tower. We have heard that we are go for the catch of the booster.
Oh, yes.
Yeah, this coming from one of our long-range tracking
have a go on
cameras. We're able
catch.
to see the hot stage separate and fly away. So coming up in just about 30 seconds, we're going to look for the landing burn. We're going to command those 13 inner and middle ring engines to turn on. 13 initially, they bleed off all of that velocity as we're slowing down from supersonic speeds, eventually moding down to only 3 engines for that precision flight into the tower.
Right now, booster using its 4 hypersonic grid fins to help guide itself through this atmospheric entry back for its precision landing at the launch site. Once again, we're going to ignite first the 13 engines to see that coming
Here it is. Awesome, that's why.
Wow. That will never get old.
All right. We saw 12 out of 13 light for that landing burn.
All
Booster
right.
still able to make its way with that final precision
Well,
burn
there.
on the 3
Now it's not
engines
as loud. Is that
in
better?
for the tower catch. So Booster caught. Meanwhile, keeping an eye on ship. Still got 6 Raptors burning.
And
Those are
then-
going to continue
Hold up.
for about another
For this one,
minute
because-
until we'll get
yeah,
to
here we go.
the Starship
make it
engine
quieter.
cutoff.
This time.
Really cool view. Again, a million shout outs to all of our avionics team who make these cameras possible for us. That's looking right down inside essentially the skirt area of
The
ship,
song is fitting,
where
right?
you can see a pretty good view of all 6 Raptors, especially those 3 inner ones, one of which we're going to hopefully relight a little bit later.
Oh no. What did they do?
And we just saw some
Yep.
engines go out.
Yeah, that's not.
It looks like we
It's
are
not
losing
supposed to go that
attitude
fast.
control of the ship.
Oh no. Is it gonna terminate? Or is it gonna keep tumbling? With its engines on. Oh, look at the fuel. There goes all the fuel. Well,
So we're still
no, I think
getting video down from the ship. You can see
yeah,
we've
'cause
lost
it's
several
spinning. You
engines
can
and
see
we've lost attitude
the fuel
control of the
sensors
vehicle.
are matching that. Oh, that's weird. Also, I gotta say, this is the most viewers I've ever had on a stream before. Anyway, oh. Yep, I think that was it. No, wait, it's still going.
So we'll continue to stick with it.
Yeah, there goes another engine. Dang
For
you,
those of you
Block
that
2.
have-
Stop doing that.
For those of you that just recently joined us, we had a successful liftoff of the 8th test flight of Starship, followed by a successful
on. Give us
stage
cameras.
separation. We saw the booster, actually, you
Wanna
can see
watch
it
it.
just behind us here. The booster had a successful catch back at the tower. Unfortunately, it seems as though we lost the
yeah, no.
attitude control of the ship.
I think,
We are
I think
standing
that's
by
it.
as we listen in with the teams
Yep,
on
there
the
it
nets
goes.
to understand what information we're able to provide you. We will provide that as soon as we are able, but it's pretty incredible to take a moment and see the booster just behind us. Certainly
Yeah.
a different view than last time.
And at this point, we've essentially lost contact with the ship. We're no longer
Yeah, there
receiving
it goes.
telemetry at this moment. So we were only about 20 seconds away or so from the end of that ship ascent burn. We saw several of the engines start to cut out. Once you lose enough of those center engines, you're going to lose attitude control. And so we did see the ship start to go into a spin. And at this point, we have lost contact with the ship. So we're going to listen in for a little bit.
That's just not
I
possible.
think it's
That
pretty
would be
obvious we're
funny,
not going to continue the rest of the mission today, but Just give us a couple more minutes. We'll bring you more information as it comes in.
It would have to complete a full orbit to come back, and it can't do that. For obvious reasons. Well, seems they didn't fix the issues that they had last time. But hey, at least we got to see it tumbling this time. Those were some pretty cool views. I don't think there's gonna be much more than... Isn't it worse than last time? Well, I mean... It isn't better or worse. Still lost it. I think it's better because we got to see it on board. Yeah, it did last longer. Hide the chat box. Oh, yeah, it's gonna be completely empty, isn't it? Okay. Well, let's have a moment for Block 2 Starship Flight 7, not 7, 8. Rest in pieces. Wait, how long is this? Oh my gosh, no, I'm not playing the whole song. That is way too long. Alright, well, that was eventful. Hang on,
All right, so coming back with you real quick. So can confirm we did lose contact with the ship. Unfortunately, this happened last time too, so we've got some practice at this now. We've got a lot of measures in place, like debris response areas where we coordinate very closely with air traffic control. We have a lot of measures put before we ever launch a rocket to make sure that we're keeping the public safe. Those worked last time, and they're actively in work right now. So just to recap real quick, everything we saw, we lifted off right at the top of our window, essentially at 5:30 p.m. Central Time. Booster was able to get us all the way up into space, made its way back here. It's sitting on the tower right behind us, our third ever catch. Starship ignited all 6 of its Raptor engines. It was just about 20 or 30 seconds away. We'll get exact times from the end of its ascent burn when we started to see some engines go out on ship. Eventually lost attitude control and then lost contact with the ship shortly after. So
exactly
obviously a lot to go through, a lot to dig through. We're going to go right at it. The primary reason we do these flight tests is to learn. We have some more to learn about this vehicle, but we're going to be right back here in the not too distant future, and we're going to get a ship to space.
Yeah, you're absolutely right. We fly to learn, and we're learning a lot. And as is the case with developmental programs such as the Starship program,
why was it so loud?
So at this point, we're going to close out our webcast for the day. But before we do, we'd like to give a shout out to our viewers, of course, as well as our partners.
Yeah, there's a million of them.
Excuse me,
for you.
here in Cameron County and around the world. Now, once we know more about the mission today, we'll provide you with updates on SpaceX.com as well as at SpaceX on X. As always, thanks for watching, and we'll see you next time.
All right. Well, that was another flight. In fact, if you didn't know. So it did exactly the same thing it did last time.
I lost Starship again.
Oh my gosh, you exist! I forgot you were in here still. Hello. But hey, we did get to see it tumbling. But I think that's gonna be it for this stream.
Hello.
Because there isn't much more to cover.
Hello.
At the moment.
Okay.
Yeah, you haven't heard any of my commentary, so.
Yeah, I know.
Hey, you told me to mute, man.
Yeah, I know.
There was something I was gonna say a little bit ago, and I just never did, and now I don't know what it was.
Yeah, bruh.
Well,
So,
I guess I'm gonna end stream now.
hey, why do you have a BS?
Wait, I remember now. I remember.
Dude, why do you have a BS manager?
Why are you talking about my desktop?
You have a BS manager.
There, now you can't see it. So anyway. Right. I figured out where YouTube was getting its incorrect measurements.
Oh, did
But
you?
yeah, see, that makes sense. So I was like, 37 viewers, and I click on participants and there's nothing. I'm like, oh, I see. It's because everyone who chats counts as a participant. Anyway, I'm gonna shut up now. See you guys. Goodbye. I hope there's more views from people.